Hey guys, 7-1, starting a new chapter. So I want to talk through a couple of things. There's going to be a lot of pausing for you because there's going to be a lot of copying down vocabulary or some identity type of stuff. So I'll make some comments about when to pause and copy some stuff down. I'm going to give you guys a little bit of background, and then I want to spend a fair amount of time going over some of the examples that we didn't necessarily have time to get to in class. Um, when you talk about identities of things, you're talking primarily even just about what something is. The example I'm going to use here of what we're going to end up doing is going to be, like, for example, between Batman and Bruce Wayne. Okay, same person, different identities. What they do, they do different things, but it's still essentially just the same person. There we go. Okay, so anyway, it's the same person, but they do different things in different places, and they obviously look a lot differently. So that's what we're going to talk about now. The first round of identities, and a lot of this is going to be review, but you still need to write them down. I would get one sheet of paper where you keep everything on and use it as a reference sheet. Write these down as much as possible. So sine is 1 over cosine, cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. Cosecant is 1 over sine, etc., etc. I would pause here and make sure you have these written down. Likewise, now, another place to pause in a moment, tangent and cotangent, sine and cosine. These come back from the unit circle stuff again. Remember, the unit circle have values of the coordinates of cosine comma sine. Again, pause, make sure you have these. We talked about these in chapter 5. Now again, unit circle time, and this is where the next set of identities are, and we've kind of talked about this as well, but just to review. So remember, the coordinates here are cosine x and sine x, mostly because our hypotenuse on the unit circle is 1. This is my opposite side. This is my adjacent side. This is my hypotenuse. And so because of that, opposite over, opposite over adjacent, so opposite over, oops, wrong one, sorry. So opposite over hypotenuse is sine, and since it's over 1, it's just the opposite side, and the same thing here. So because of that, we get this, what's going on. Now remember, how are the legs of or the sides of a right triangle put together? Well, remember, we've got legs squared plus legs squared is equal to hypotenuse squared. Now in this case, that's the Pythagorean theorem. Our legs, however, now are cosine and sine. My hypotenuse is 1. And that's called the Pythagorean identity. And that is written right here. Ta-da! So the cosine squared plus sine squared is equal to 1 for the reason why we just went through. And if we divide each side through by cosine, we can start getting the other 4 cousin, well, not tangent isn't really a cousin function, but the tangent and the cousin functions along. Because now notice, if everything has a denominator cosine, cosine over cosine is 1, sine squared over cosine squared is tangent squared, 1 over cosine squared is secant squared. And likewise, if you do the same thing with sine, you end up getting cotangent squared plus 1 is equal to cosecant squared. And again, pause, copy, and continue. Now here, again, real quick, if I've got x, this would be the opposite of x in terms of arc lengths. This point up here would be cosine of x, sine of x. This down here would be cosine of x, the opposite of x, sorry, and the sine of the opposite of x. And so because of that, now watch what happens. You've got, man, I like green today for some reason. So I've got cosine over sine, or these cosines of x's are directly over each other. And so the upshot of all of that is going to end up being then cosine of x is the same thing as the cosine of the opposite of x. Now, because sine is the y value, remember up here in quadrant 2, I've got plus, minus, and minus, minus down here in quadrant 3. Then the sine of x and the sine of the opposite x are opposites of each other. And so the way that they write that down is that we're going to say that that's opposite. So for that, we end up coming up with 3 basic identities, and these are all called the negative angle identities, because what happens if you're going the opposite angle of the opposite radian measure? And so you get these 3 here. And again, remember, sine is opposite signs because you're talking in quadrant 1 and quadrant 2. Oops. So if we got this, positive, positive, negative, positive, negative, negative, positive, negative. And so sine, being the y values, are always going to be opposite of each other. Okay, you've got this, these 2 are together, these 2 together. Those are always going to be opposites, even though they're directly over each other and they match up. Likewise, however, in the cosines, those are going to be matching there. Now, since tangent is sine over cosine, okay, if sine is not changing, if sine is changing but cosine's not, then you're going to change the signs on those. Now, likewise, the cousin functions have a similar thing going on here, because sine and cosine, or sine and cos, you can't remember, just reciprocals of each other, so the signs are going to stay the same, and the 2 values are going to, you know, etc. So, again, pause and write them down. The most important thing here is you need to know these. You're not going to be able to get a flashcard on these things, or you need flashcards, or use an app or something like that, so you don't need to keep on going back and looking things up. Okay, for these identities in particular, I'm not going to let you guys have a note card or anything like that, so make sure that you really take some time, whatever memorizes, works best for you to memorize them, do it. A couple of examples. Now, what we're going to end up doing here is we're going to take the expression on the left and we're going to make it the one on the right. Usually, you're going to work from more complicated to less complicated. And the answer is the entire process. It's kind of like saying, all right, you're going to go from Chicago to San Diego. A bunch of different ways you can get there. But the whole process is, you know, you have to still explain what you did to get there. So, a couple of things. Hey, look, I'm back at green again. All right, so I'm going to start with this. I want to eventually turn that into tangent squared x. So, a couple of different things. First of all, notice I've got 2 terms here, and I'm going into 1 term. When you're simplifying that way, one of the best things you can do is you can see if you can factor things out. If you can't add them together, factoring is going to be helpful, because if you can factor stuff out, now notice this is an addition equation. If I factor out the commonality, which is the sine squared x, I now am multiplying these 2 things together. And now I don't have 2 different terms. It's kind of like one basically big term. And then from there, you can start doing some things that are interesting. Now, note here, again, you don't always have to explain your reasoning. I'm just doing this so you can see it. So we're factored out sine x. Now, as I said, whenever you do any of the Pythagorean theorem identities, you should really kind of have a bell going off the back of the head, back of your head, anytime you see a 1 and a squared term, or 2 squared terms together. So right now, if you look at the 1 plus tangent squared x, look at your reference sheet. So if we go back to that Pythagorean, hey, look, oops, too far. 1 plus tangent squared x is right there. What's that equal to? Secant. Nice. So this, by your Pythagorean identity, is now going to equal, what do we say, secant, right? And again, remember, one way to say, remember that secant is 1 over cosine, tangent is sine over cosine, that would work. And then that, now again, remember, the other way to do this, and you may remember this from geometry, is if you see tangent, you've got to think, wait, that's like sine over cosine. So with that in the back of the head, we already have sine. So we don't really want to mess with sine around too much. But secant I can write as that. You can say, I would just simply say definition is fine for a reasoning. And then from there, you're just going to go through and do the math. So now that's going to equal, and actually we probably should have equal signs here. So that equals this, that equals this, that equals this. And then I'm going to get sine squared x over cosine squared x. When I simplify it, and then that's going to equal tangent squared x, and that's by what, the quotient identity. And then you're done. And when you're done, put a nice big check mark there. We'll slap in a little quod erat demonstratum, or quite easily done. It's to signal to the reader that, hey, you know what you're doing. Now, some of them aren't necessarily even more, you know, again, rewind as you need to. Some of them are not necessarily even that complicated. Oops, too far. So like for number 2, there's a couple of different ways you can do this. So, number 1, solution. A lot of times people are going to see the original and say, wait a second, I've got cosine and cosine. Please just remember to break this apart. Okay, so you're going to say, all right, I'm going to break this up into 2 different parts. So I'm going to get sine squared x over cosine squared x, and that's going to equal, oops, not equal, plus cosine squared x over cosine squared x. I'm having problems writing. And then from there, that's going to equal, this is going to become tangent squared x. This is going to become 1. And then by Pythagorean identity, that's going to turn into secant squared x. Not too bad. Now you could also do it this way, because again, remember, just like down here, when you saw the squared term in the 1, you should be like, hey, wait, that's important. You should also remember, hey, wait, I've got 2 squared terms up here on the top. So if I had this, the fact that I have sine squared x and cosine squared x should be, again, tipping something off for you. That it's a Pythagorean identity. In fact, it's just going to equal 1. So from here to here, your Pythagorean identity says cosine squared plus sine squared equals 1. So you get 1 over cosine, and that equals sine or secant squared x, and you can do it either way. And again, that shows you can do it both different ways, get the same answer. One seems a little bit more easier than the other, but if you're not seeing it, you can still go through and do it the same way. Last one. We're going to show that tangent x, cosecant x, and secant x is equal to 1. When you have something like this that doesn't have any like real straightforward, you know, hey, I'm going to break it up or anything like that, what I would end up doing is you just write out each of the parts individually. So I'm going to write this as tangent of x times cosecant of x times 1 over secant of x. So that's just simply rewriting it. And one of the rules that you're going to learn to do is that when in doubt, if you get stuck, change everything into sine and cosine. So if I do that, tangent now is going to become sine of x over cosine of x. And here's the whole reason why you change everything, because now cosecant is 1 over sine x, and secant is cosine over 1 over secant is 1 cosine x over 1. And so now at this point, everything starts to simplify out. Sines of x's divide out, cosine of x's divide out, and that's going to end up equaling 1. Okay? So if you get stuck, just simply writing everything in terms of sine and cosine can be a very good way for you to just, maybe get a push in the right direction. So anyway, so that's the first day. We're going to spend some more time on doing some more examples tomorrow, and then all next week. So talk to you later.